Ladies and gentlemen, ladies and gentlemen, boys and girls, welcome back to another video. Here we're going to be doing our our final exam reviews. So for the other exams, I want you guys to go ahead and take a look at the review videos I made for exams 1, 2, and 3. But here we've got practice test 4. I'm not posting it because I don't want to cause confusion about tests or whatever, but you can just watch this video and see all of the questions for this. This is going to be like your integral test, right? We only have 3 exams, normally they have 4, so this is our difference. Okay, so we're going to start off, if f is 0 on the interval, then the integral of f is 0. This is obviously true, right? What is the area under the curve of 0? Now, it does not go the other way around. You're saying if the integral is 0, then the function is 0. That's obviously not true, right? Because what if you just take any odd function? Odd just means that f of negative x is the same thing as negative f of x. For instance, this guy here, right? Here, our negative area cancels out with our positive area. So you would not have the same going the other way around. All right, here, suppose g is the function given by the graph below. We've got this circle here, basically, and we want to follow, we want to evaluate this integral from 0 to 4 of g. And you're like, ah, man, I don't even know what the equation of a circle is. It's not given. Well, we have 0 to 4. So we want to find the area under this curve, and so in other words, you know that this is a circle of radius 4, and it's a quarter of the area, right? Because the area under the curve. You would not be counting anything down here. The reason you wouldn't is because that would make this not a function. It, like, you know, if we were going to start going under here to encapsulate the you know, the area, we're doing the area under the curve. This is how you do integrals, right? It's the area under this curve here when you go down to the x-axis. If we wanted to bound it by this bottom one, we'd actually have to change our integral bounds. So anywho, what's the area of a circle? It's going to be pi r squared. So pi is pi, and then r squared here would be 16, so 16 pi, right? We just have a quarter of that, so it's going to be 4 pi. If I'm using a Riemann sum to compute the integral, which of the choices of the number of regions below will give me the most accurate estimate, right? The more regions you do is always going to give you the best estimate, right? So it's going to, you know, we're going to be taking more and more of these tiny little rectangles, so 142 is definitely going to be the answer. Suppose f is the function pictured below here. If I'm using Riemann sums to estimate, would the value of the left or right Riemann sum be greater, right? So if we start here, we make a little rectangle, and then we make a little rectangle. We do our left rectangles. Well, you notice, let me even draw this here. Just so we can picture it. Not, you know, tweaking. Okay. Let's go in here. And so if we had, you know, if we started drawing our rectangles like this, using the left endpoints, well, you see how all of our error is above the curve, right? Now, alternatively, if we did our our right endpoints, you'd notice that all of our error is below the curve, right? So we're like missing this area instead of gaining more area. So here we would notice that the left Riemann sum would give us a greater value. Okay. Compute the average value. Yeah, we can do that. Okay, so it's going to be, I mean, we're actually going to compute it, but we'll at least set up the integral. For any of these problems, you can expect to just be setting up integrals. Also, the final exam, I'm planning on doing 10 questions, 1 multiple choice. No. 10 questions. It's going to be 2 from chapter 1 stuffs like limits. It's going to be 3 from... It's going to be 2, 3, 3, 2 in terms of the sections. So there'll be 2 from integrals, this new stuff, and there's going to be 2 from limits, and there's going to be 3 from derivatives and optimization. Actually, that's subject to change, but it's going to be something like that, okay? So I'm not going to give you the total breakdown because I actually might change that. But there will not be chapter 5, like solids of revolution or whatever. I'm not going to test that. So the only thing that I'm testing to is going to be just integrals. Okay, here we've got f is going to be 2x squared over cube root of x. And we know that x squared over cube root of x is going to be what? Well, we've got 2 powers here. We've got a third power here. So in other words, it's going to be, what, 5/3, right? Because 6/3 is 2. So here we've got 6/3 power up here, negative 1/3 power. That makes us have 5/3. So f is going to be 2x to the 5/3. Now, what is average value? And we normally take an average. You know, if I took an average of three numbers, 3, 4, 5, I would do 3 plus 4 plus 5. I'd add them all up, get all of my mass together. This is all the mass that's in this group, and I'm going to divide by the length of the group. And when we say the length of the group, normally when we're just counting numbers, 1, 2, 3, that's just 3 things, right? It's how many things. Each number is worth 1 length. So this is how you do an average normally. But with an integral, now we've got, instead of just a finite set of numbers, now we've got an interval. So it's going to be like, well, I guess, okay, we've got a function on an interval. So here, now we've got a function on an interval. We're going to have we're going to get up all the mass. We're going to sum up all the mass. And what is a sum, kind of, in this continuous sense? Well, it's going to be the integral. So average value is going to be the integral from 0 to 4 of 2x to the 5/3 dx. Don't forget your dx. And we notice that this is going to oh yeah, and then we have to divide. Okay, I'm sorry. So you divide by the length here. It's the exact same thing as like dividing by how many numbers you're doing. But here, our numbers, since we're doing infinitely many continuous points, we have an infinite amount of numbers. We're not going to divide by infinity. We're going to divide by just the length of the interval. What I like to do, just for consistency's sake, is I like to say 0 to 4, 1 dx. You don't have to do this. You could just write 4, right? You could just write 4. But when you get to Calc 3, this is going to be more, you're going to have a bit more steps. So here we'll write 4, but just know that it's the integral of just 1, right? Okay. So that would be your answer. I'm not actually going to anti-differentiate this. Just kind of am in a rush a little bit. But that's how we would do it. Okie dokie. If you guys have any questions, feel free to email me. Okay, G prime. Let's get this. Let's do some fundamental theorem of calculus. Whenever you see primes and derivative, or primes and integrals being interchanged, it's going to be fundamental theorem of calculus. So what does the fundamental theorem of calculus say? The fundamental theorem says that if f of x is going to be like integral a to x f of t dt, then we know that, or I guess, okay, maybe we'll put g of x up here. Then we know by chain rule, we're going to say that f prime of x is going to be f of x dotted with g of x. G prime, sorry, I'm tripping. Okay, so what do we do here? Well, all we're going to do is we've got, f of x, would be this guy here with the x's, and then g is going to be sine. The only difference here is we do have to flip these bounds, right? So g, because the way that we have it written is with g in the top. So that's an important distinction. Here, g of x is going to be, we'll maybe box this or something. Oops. We're going to say g of x is going to be negative integral 9 to sine x, right? T cubed minus 5t squared plus cosine t dt, right? So now, what do we do? G of x, we've got this guy. So now we can just do our formula, right? So g prime of x is going to be what? Well, we know it's going to be x cubed minus 5x squared plus cosine of x. It's just going to be this inside part with x plugged in, of course. We should not have any t's because t is what we're integrating. And then now we multiply by the derivative of, and this should be actually a negative here. And then we multiply by the derivative of our g here, but g is sine. So this just means we're going to have cosine x. This would be your answer here. Okie dokie. Let's go down here. We're going to integrate ln. Let's do it. Okay. Integral of ln. You think, okay, well, ln just integrates to 1 over x. That's clearly not the case, right? Because, I mean, that would just be immediate here. What we do know is we know that integral of 1 over x is ln of x, right? This is our, plus c, whatever, it doesn't matter. So make sure you do remember your plus c's. That actually is important, but I just, for thought, it doesn't really matter. Okay, so we have 1 over x dx is ln x. So what do we kind of want to use that here, right? So here we're going to say that u equals what? When you think of integration by parts, you want to be, well, let's pull up our formula here. You're going to be, I don't like to think of it the way that, oh, whoops. Okay, we're fine. I don't like to think of it as, see, they kind of do like this, like weird matching stuff. Like you got UV and then you match. Really what you want to be thinking of is, okay, maybe this will be more, helpful. No, I don't like this. This is, basically with integration by parts, you're going to be losing a derivative and gaining a derivative. This kind of shows it more. Right, you've got u and you've got dv. This turns into v and du, right? So you notice how our v gains an integral and our u takes a derivative, right? So that's kind of how we want to be thinking about this. So here what we have is we want to be keeping this guy in mind here, but really the integral of ln x. This equals ln x times 1 dx, right? So if the integral of 1 over x is ln x, then the derivative of ln x is 1 over x, right? So this means that we kind of need this to be the guy that we're taking a derivative, right? So u is ln x, which means that du is going to be 1 over x, right? Now, this means that dv is going to be 1 dx, which means that v is going to be what? Sorry, this should be dx. V, what's the antiderivative of 1? Well, it's just going to be x. Right? So now we do, so now we can do our integration by parts. Integration by parts is testable. This now equals uv. So it's going to have our boundary term. And when I say boundary term, ln x times x, this has to be evaluated from 2 to e, right? And now this is going to be minus the integral from 2 to e of, and we switch our stuff around. So we're going to have x times 1 over x dx. Right? If we look at our formula here, we've got our boundary term uv. Okay, so this doesn't have the bounds. But it's important on this uv that you put your bounds in, right? Because if this is bounds, this should just end up being a number. So we need to put bounds in here so we're not left with x's or anything like this, right? So now we've got our boundary term uv here. And then we have v du. V is this guy and du is this guy, right? So now all you have to do is just plug stuff in. So this is going to be ln of e. Well, what is ln of e? What is ln of e? Ln and e cancel, remember? So this is just going to be 1. It's like ln of e to the 1. These guys cancel. Bing, bing. And you're left with just 1. So we're going to have 1 times e minus 2ln2. Right? Now, we're going to have minus the integral from 2 to e of 1 dx. So we're just going to be left with e minus 2ln2 minus e minus 2. Make sure you keep this parentheses, right? Because this 2 should be positive. And so now the e is going to cancel with this e, and we'd be left with just, I mean, you could leave it like this on an exam, but we would just leave it here as positive, right? That's going to make that negative sign makes the 2 positive, so it's going to be 2 minus 2 ln 2, and you could even factor out a 2, right? And this would be your final answer. Okay, that'd be it. Compute this antiderivative, show your work best as you can. What I would probably do for this is I would just, because, right, this is not like, we don't immediately know how to do this. You've got different options. The first option is we know that the definition of absolute value of x is going to be the square root of the square, right? Because square roots we've defined to be always positive. This is just how like convention works. So we say that square root of a squared equals absolute value. You could do something like this, but really that's not going to help you very much actually, because you need to do some kind of like, you know, we're integrating, we need to have then like for our u substitution, we wouldn't have anything. So here what we're going to do is I would just say that this this equals the integral from -2 to 4 of, and what is our function? Well, we know that absolute value of x is going to be -x when x is less than 0, and it's going to be positive x when x is greater than or equal to 0, right? Dx. So all we can do is we just say this is going to be the integral from -2 to 0, and really there's this inclusion of 0 doesn't really matter where you put it, right? This is going to be -2 to 0 of -x dx, right? We're going to take the negative part because it's going to look like this. So what we're doing is we've got our function is like this, and we're going to say, you know, this integral here is this integral where it's just -x plus this integral where it's just positive x, right? That's what our strategy is. So here, what do we do? What do we do? I don't know. -2 to, oh yeah, okay, and then we add plus integral 0 to 4, right? X dx. And now this is like very simple, your mom could do it. So maybe I'll leave this as an exercise just because, you know, it's like very easy to finish. Okay, if you have any questions, feel free to email me. I will see you all, well, I guess I won't see you again. I hope that you all have a wonderful time studying for the final exam. Feel free to email me whenever you want, especially coming up to this exam. I will be trying to look at my phone over the weekend, but I don't know how much I'm going to be able to be on it. Yeah, for the first three, just review the previous three exams. The exams that I gave you are super useful. So like the actual test that you took, right? Exam 1, exam 2, exam 3. Also the practice exam 1, exam 2, exam 3, and like the videos that I've made with those. And then for this exam 4, right? It's, you know, the integral test. It was not an exam, but it's definitely testable material. Make sure that you just watch this video, have a good idea on how to do all these problems, and do your web assignments, and you guys should be straight. All right, I hope that you all have a wonderful day, and I will see you probably never again. Goodbye.